Electric circuits only. This is quite lengthy chapter. Electrical circuits only. Electrical circuits. Today we do some more problems. Write a question. Two cells. E1 and E2. Two cells E1 and E2. Two cells E1 and E2 of EMF 4 volt and 2 volt respectively, of EMFs 4 volt and 2 volt respectively, 4 volt and 2 volt respectively, each having an internal resistance, each having an internal resistance 2 ohm, send current in an external resistance of send current in an external resistance of 8 ohm, external resistance of 8 ohm. Stop. Find the magnitude and direction of currents. Find magnitude and direction of currents. Find magnitude and direction of currents. I1 and I2 flowing through the cells. I1 and I2 flowing through the cells. They are given a diagram here. Circuit also given. This is 8 ohm. This current is given. The question is I1. This question is given as I2. And here it is given, already given, otherwise we know that I1 plus I2 will get to be the real rate because I1 plus I2. And they have given this, the value of 4 volt, 2 ohm, 2 volt and 2 ohm. Internal resistance is given here. Instead of the internal resistance being given here, they may give a comma here. They may not try to show up here. They may write here 4 volt comma 2 ohm. 2 volt comma 2 ohm. That is the internal resistance. So this is the circuit given. Now, how to find the value of current? I will give the name of these points randomly: A, B, C, D, E, F, and give the name. I'll take the loop, closed path, one by one. There are two unknowns, mainly I1 and I2. We'll find two quantities by having two equations, solving them simultaneously. First equation I'll take from here, from the first cell. Suppose if I'll take the loop like this, or in the network like this, right? Then in the loop, A, B, C, D, F, A. If you want, you can name E also, but E doesn't matter. You can just say A, C, B, F, A. I am taking this way. So what are the currents out here? Here I see only one. So this is coming 8 times of I1 plus I2. Then of course I2 will go back to its own source and I1 will go back to its own source. So 8 I1 plus I2. 8 I1 plus I2 plus 2 times of this I like here. 2 times I1 equal to 4. So make equation out here. I can see 8 I1 plus 2 I1 becoming 10 I1 plus 8I2 equal to 4. Divide by 2 everywhere to make it smaller. We write 5I1 plus 4I2 is equal to 2. Mark equation 1. Okay. Similarly, I take another loop. Another loop I take this way. Another loop. Right. In the loop, next loop is in the loop BCDE. Closing it. This one. BCDEB. Again, I write here 8 times of I1 plus I2 plus this one also to take 2 into I2. 2I2 is equal to 2 volt. I will open bracket. This becomes 8I1 plus 8I2 plus 2I2. 10I2 equal to 2. Dividing by 2 everywhere, we get 4I1 plus 5I2 is equal to 1. Equation number 2. Now these two equations we have to solve simultaneously to find the value of I1 and I2. Let us solve them. So I think first equation multiply by something, second equation also to by 4 here and by 5 here, and write down here 4, 5, 20I1 plus 16I2 is equal to 4 to the 8. Next will come 5 for the 20I1 plus 25I2 is equal to 5. Change the sign everywhere, cancel. You get minus 9I2 is equal to 8 minus 5 is 3. So I2 value is coming 3 by minus 9. The answer is coming minus 1 by 3. That is minus 0.33 ampere. That is the value of I2. Putting the value of I2 back in any one of the equations and find the value of I1. From equation 1 now. From equation 1, 5I1 plus 4I2. I2 value is minus 1 by 3 equal to 2. Now I find the answer of this. 5I1 is equal to 2 plus 4 by 3. 3 to the 6, 10 by 3 is coming. Therefore, I1 value, I cancel it, become 2 by 3 ampere, that is 0.67 ampere with a positive sign. So, I1 value is this much and I2 value is this much. Now, we'll have to write the direction also. Let us write the direction, right? Therefore, I1 equal to, concluding answer now, therefore, I1 is equal to 0.67 ampere. Since the sign is coming positive sign is which way it is positive is in the same direction as shown in the figure. So in the same direction, that means what direction it is clockwise. Here we can write clockwise. And I2 is coming minus 0.33 ampere. Minus is the sign coming. That means in actual situation, the direction of this current is opposite to the figure, and whatever is shown in the figure is opposite to that direction. In the figure it is shown in what direction? Flowing clockwise, but in actual situation it is flowing in opposite direction to that, that is anti-clockwise. In actual situation, anti-clockwise is the answer. Alright? So this problem is solved. Yes. Though I will tell you one more, there is one more way of doing this problem. And what is it? I will show you. Of course, using Kirchhoff's law. I can take the loop even this one, A, B, E, F, and I will get the same answer coming. First, I took this way free, like this way I took and made one circuit, another one I took like this, made another equation and solved them and got answer. One I take like this and second equation I will change. If I take this way, just have a look at it, you may not copy, just have a look. I take the loop this one, A, B, E, F. In the loop A, B, E, F, A. If I take the loop this way, how I will take equations now? I will take the equation first. this way I am taking, but whereas this current I2 is going this way, so the minus sign, minus 2 I2, I will write here minus 2 I2, minus 2 I2. Why minus 2 I2? Because I am taking the loop this way, where the current is going in this direction. Current and resistance to multiply. There was no resistance coming here. Resistance comes here, so minus 2 I2, opposite direction. Because current is going up and we are taking this way. And out here plus 2 I1. Plus 2 I1 equal to, what is the EMF of this one? Positive 4. But this one is giving the current opposite direction, as these two EMFs are in opposition. You can put a minus sign here, 4 minus 2. If they are giving the current the same direction, we will write plus. Now, this will become, I write from here, write 2 I1 minus 2 I2 is equal to 4 minus 2 is 2. Dividing by 2, every we are making it smaller. We get I1 minus I2 is equal to 1. Equation 2. If I solve this equation, I will get the same answer what we got just now. I will just multiply this by 5. And this one I will keep as it is. I will solve it. I will just show you, you may not copy, just have a look at it. 4 sorry, this is 4 I2. I am not multiplying this by anything. Equal to 2. Second equation I will multiply by 5. 5 I1 minus 5 I2 is equal to 5. Minus become plus, this one 5 plus 4 is becoming 9 I2. 2 minus 5 is minus 3, so I2 value is coming minus 3 by 9. Answer is minus 1 by 3 ampere. I think you got the same answer as the previous one. So this way also this could have been done. I mean to say that. We could take the loop even this way, the battery to battery also we can take it. So either of the way we can do it. But of course using Kirchhoff's law. Okay, write one more question, then we'll do the other thing, right? Find the PD across, find the PD, potential difference. Find the PD across 5 ohm resistor. Find the PD across 5 ohm resistor. 5 ohm resistor as shown in the following circuit. As shown in the following circuit. Okay. We are showing a circuit like this. Across which ohm? 5 ohm. Across 5 ohm. Okay. Here is the question. Most probably in the question they will write using Kirchhoff's laws. Using Kirchhoff's law you have to do. Okay. Now see, first we will be giving the name of these points as A, B, C, D. I can start from the any current first. I mark this current. If it is not given the question, we will mark ourselves. This is I1. Current of this is I2. From the positive side, it will start. Now I will see how these currents are running in the circuit. This current will be running in this manner, like this, like this, like this. Will be doing so. I1 current is going this way in the circuit, running in this manner. And I2 current, how is it running in the circuit, is going this way, from positive to negative way. So I2 current is coming in this manner. This will be I2 to the source, back to the source. Here in this region we see this current I1 and I2, they are in opposite direction. This one is going like this and this one is coming this way. They are in opposite direction. So net current will be always subtraction. Normally we will do bigger minus smaller. So I2 it should be bigger because this is from the greatest EMF 4 volt. This is 2 volts. This will be weaker current. This will be stronger current because of the higher EMF. So net current flowing out here will be I2 minus I1. And what direction will it will flow? It will flow in the direction of the bigger current. I2 minus I1 will flow in the direction of the bigger current. The bigger current is I2 in the direction of I1. So now I take the loop or the network vector in the loop. In the loop, I will give the name of the loop. Any loop randomly I will give the name. Suppose I start from here. I will give the name here BC BCAB closing it. Okay. First I will be writing this one I into R 5 times of this. 5 times of I2 minus I1. This is going plus 2I2, same direction plus 2I2. I should not forget this internal resistance. Internal resistance also to be taken into consideration. 1 into I2 plus 1 into I2 plus 1 into I2. Internal resistance part will always plus. Either we take this I2, 1 ohm we can assume to be here or assume to be here, it will be always plus. So plus 1 I2 is equal to 4. So write 4 volt. I will simplify and make equation 1. Minus 5 I1 I write first. Minus 5 I1. 5 I2 plus 2, 7 I2 plus this becoming 8 I2 altogether is equal to 4. Equation 1. Now I take another loop. From here I will take from the positive terminal of the cell I should take. So I take this way. In the loop ACDA. In the loop ACDA. First I will see this one, but the direction of this one I am taking this way I am taking, whereas the direction of this current is coming like this, the opposite, so minus sign should be. Minus 5 times of I2 minus I1. Here it is in the same direction, the plus 3 times of I1 equal to, and not to forget the internal resistance, not to forget, plus 1 times of I1 is equal to 2. Here the key point, many of the students they forget about the internal resistance, that should not be forgotten. Now we simplify and make another equation here. Minus plus 5 I1, 5 plus 3, 8 plus 1 is becoming total 9 I1. Minus 5 I2 is equal to 2, equation number 2. After this value, what should we do? We should solve the equation simultaneously and find the value of I1 and I2. Let us multiply and solve. Multiply this by 9 times, multiply this by 5. 9 into this is coming minus 45 I1. 9 8 is 72 I2. 9 4 is 36. 5 9 is 45 I1 minus 4 5 is 20 I2. Sorry, 25. 5 2 is 10. I should add them so that this gets cancelled without changing the sign. 12 minus 5 is 7, 47 is coming here. 46 is coming here. So I2 value is coming 46 by 47 and here. We can get that certain decimal 0.99 something will come or nearly equal to 1. I take this value nearly equal to 1 ampere. Coincidentally it is coming like that. This was my own question, so but the exact time you will get the value coming something whole number or something like that will come this 1 ampere like that. I'll put the value back and find the value of I1 or any one of the equation. From equation 1 now. From equation 1. I'm putting the value back. Now we get minus 5 I1 plus 8 I2, that is 8 into 1 equal to 4, minus 5 I1 is equal to 4 minus 8, minus 5 I1, this is coming minus 4, I1 value is coming 4 by 5, that is 0.8, nearly 0.8 ampere. 0.8 ampere. But we have to find PD across this one now. Therefore, we write down, sir. Therefore, PD across, PD is voltage. PD across 5 ohm equal to I into R. I do, that is I2 minus I1 into R. Resistance is 5 into 5. I2 value is how much here? 1. Nearly 1. So 1 minus, and I1 value is 0.8 into 5. This is coming 0.2 into 5. Answer is coming 1 volt. Approximately 1 volt. And after calculation also you can see the value of I1 and I2. The value of I1 and I2 is coming. I1 is big, I2 is bigger because this I2 I assume bigger because this is 4 volt. I2 is coming bigger than this one. So the answer is 1 volt. Okay. Now Kirchhoff's law is very useful even in finding the resistance, total resistance of the complicated network. So write a question. Find the total resistance. Find the total resistance of the following cube between any two opposite corners, if R equal to capital R equal to 2 ohm, if capital R is equal to 2 ohm, and draw a diagram. They are showing in a diagram resistance. There is a cube given in this. We'll make a cube first. Each one is value given R. Resistance on each side is R. Resistance of each side is R. Each resistance is R. This circuit is quite looking complicated type. Each one's value is R. They are showing a cube. The resistance of each side of the cube is R. Okay, and they are asking find a total resistance between any two opposite corners. Within any two opposite corners. Okay, how to find? There we will be using Kirchhoff's law and find the total resistance. And for that, suppose I take the corners, any two corners I take opposite corner. So it's maybe one corner here and one corner here I will choose. This is A and this is B. Opposite corner. Or you can choose this corner and this corner, any two opposite corners, diagonally opposite. These two corners are diagonally opposite. Okay, now see how we are doing it. So from here we will be sending current to the circuit entities between A and B only, between A and B from a source of V. This thing I will draw ourselves. Total current flowing is suppose I. We will distribute the current and then we'll apply Kirchhoff's law and find total resistance. For the sake of convenience and easiness, what we will do, we will take the total current as, because this current is getting divided, I will take the total current as 6I. 6I. We can take even I also, but I will take 6I, it is easier. Out of 6I, we will see what is happening here. This 6I on coming is dividing into two branches here, two parts. This current will be 3I and outward current will be 3I. Current will be equally divided. Why? Because the resistances are equal. So 3I here, 3I here. Again, when 3I comes here, it is dividing into again two parts. So what are the two parts? This will be 1.5I, 1.5I. No, sorry, it is dividing into, this 6I is dividing into, I made a mistake. This 6I is dividing into three parts, three branches here. Yeah. This is 2I, this is 2I, this is also 2I. Three branches are there, sorry, I made a mistake. 2. There are three branches, one here, one here, one here. Three branches are there. So 2I, 2I, 2I. Now as 2I comes here, it is dividing into two parts. This will be I, this will be I. Again, this 2I comes here, dividing into two branches. This will be I, this will also be I. Okay. Now, this 2I will come here again, dividing into two branches. This will be I, this will also be I. This I will continue here, this I will continue here, that is, this will become 2I. 2I will come here. 2I comes here, I and I. So this I will get together, become 2I, will be coming here. This I will also, and this I will again get together, become 2I. Will flow like this. The total current again becomes 6I. 2I, and 2I this way. 2I this one, 2I. Okay. Once again, see the distribution of the currents. 6I have taken, dividing into three branches, 1, 2, 3. Now 2I comes here again, dividing into two branches, I and I.
Yes, sir.
This 2I comes here, dividing into two branches, I and I. This 2I comes here, dividing into two branches, I and I. Again, at this point, what is happening? This I and this I gets together, becoming 2I. This I and this I again getting together, what here is becoming again here 2I. This also becoming 2I. The total becomes 6I. Now I take the network, you can give it offset. I take it this way, you can give the name, some name out here, make it D, E, F, G, any name I am giving out here. I will take the loop like this. From here I will take right here in the loop, G A D E B F G. G A, this way I am taking, this way I am taking, this way. We can take it any way. We can take it this way also. Like this way also we can take. This way also we can take. Any one way we will take. Any one way. Like this also we can take. This also we can take. Any one way we will take. This is the point G. So now I will be writing the current into resistance 2I into R. Write here 2IR plus what here IR plus there also 2IR is equal to total voltage V. 2 plus 2 4. This is becoming 5IR. 5IR is equal to V. This V value I write voltage formula. Total voltage formula is total current into the total resistance. Total current is 6I. And total resistance I write here R total, which you have to find. I and I cancels. Your answer become only 5 by 6R. 5 by 6R is the value of R total. That's it, answer. The circuit is complicated, but the solution is short. And now value of R is given, input value now. Therefore, R total is equal to 5 by 6 into R. What is value of R given? 2. So we put the value 2 here, 2 ohms. 2 3s I will cut, you get 5 by 3 ohm. 5 by 3 ohm, that is 1.67 ohm. That is answer. Final answer is this.
Yes, sir.
We can take the loop any case. If I take the loop even this way, like this way, then also we will have the same answer coming. Same answer will come. Here 2I R plus IR plus 2I R again, and all the answer will come same. Anyway, we will take it. This is 2I actually. I coming here, I coming here, becoming 2I. Okay. So Kirchhoff's law is even useful for finding the total resistance of the circuit, complicated circuit. Okay, this topic is over. For Kirchhoff's law we have done quite many. So now we are doing, give the heading Wheatstone Bridge. Wheatstone Bridge. Wheatstone Bridge. Wheatstone Bridge is the topic. And this is quite an important topic. What is the Wheatstone Bridge? Which electrical bridge is electrical circuit. It is a kind of circuit of 4 resistances. Okay, you can draw the circuit of Wheatstone Bridge like this way. This circuit is called Wheatstone Bridge. This electrical circuit is called Wheatstone Bridge. Okay. Here I write P, here I write Q, here I write R, here I write S. P, Q, R, S. These are the value of resistances. G means galvanometer is there, galvanometer. Such a circuit is called Wheatstone Bridge. In this circuit, when the galvanometer reaches 0, that means when the galvanometer gives null deflection, zero deflection, null means zero deflection, then the bridge is said to be balanced. You can write down here. The above circuit is called a Wheatstone Bridge. The above circuit is called a Wheatstone Bridge. Wheatstone Bridge. Wheatstone Bridge. When the galvanometer in the circuit gives null deflection, under bracket you write Ig equal to 0. Current through the galvanometer is 0. Then we can write Ig equal to 0. Ig equal to 0. Comma. The bridge is said to be balanced. The bridge is said to be balanced. The bridge is said to be balanced. Stop. The necessary condition for balancing a Wheatstone bridge for balancing a Bridgestone bridge can be derived as follows. Okay. Now we are going to derive necessary condition when Ig becomes 0 or when galvanometer gives null deflection, that is when galvanometer reads 0, no deflection. So to find the necessary condition, what I will do, I will mark this point as A, this point as B, this point as C, this point as D, and mark them. And out here the current, I take this current as I1, this current I take as I2. Of course, this total current is I value is only I1 and I2, I equal to I1 plus I2. Or I can write I1 here, then I minus I1 I can write here. So any one way we write. So I write I1 and I2. When I1 comes here, it is having tendency to be divided into two parts, here and here. But this is 0, Ig value is 0 here. Ig value we write 0, Ig equal to 0. That means the current I1 will flow through this. Entirely will flow without getting divided here. Same way I2 will flow entirely through this. And the total current again becomes I. We'll go back to the source. Okay, now we take, there are two unknowns, I1 and I2, two equations, and then we'll solve. I take the loop that is A, B, D, right, in the loop, A, B, D, A. I write I1P. I am supposed to multiply this into this ohm, but 0 into anything is 0, so forget about it. This one now. This will in opposite direction at minus I2R. There is no battery here in this part, so I write equal to 0 volt. I write I1P equal to I2R and mark as equation 1. Now another loop. In the loop, next loop I take this way. BC, in the loop BCDB. I will write I1Q minus, because this opposite direction, minus I2S, and this is 0, forget about it, that equal to 0 volt. There is no battery connected here in this part. From here I write I1Q is equal to I2S, equation number 2. I divide the two equations, like dividing equation 1 by equation 2, dividing equation 1 by equation 2. I divide the two equations. When you divide, you get I1P by I1Q is equal to I1Q I2 R upon I2S. Cancel, you get P by Q equal to R by S. So this is the necessary condition. So under what condition the bridge is balanced, Bridgestone bridge is balanced, when the ratio of the arms are equal, ratio of these arms is P by Q equal to R by S. When they are equal, then the bridge is said to be balanced. That is, galvanometer connected here in between these two arms will give null deflection, will give 0 deflection. So this is the necessary condition. Sometimes they write R1, R2, R3, R4. Will do the same way. It will become R1 by R2 is equal to R3 by R4. Sometimes they may write X1, X2, X3, X4 like that. If they give a diagram and from that diagram to derive the condition, we will follow whatever symbols they have used. And if they have not given the symbols, then we will be doing ourselves. P by Q and PQ, RS, I take that this is a necessary condition. That means when a bridge is balanced, two arms will be in series. These two arms are in series. These two arms will receive same current. These two P and Q arms will be in series. They will be having same current. And these two lower arms, R and S, also will be receiving the same current. These two will also be in series. and the two arms, I mean the upper arms and the lower arms will be in parallel with one another, the parents are divided.
Yes, sir.
And even if there is any resistance given, the value is suppose given anything 10 ohm or 100 or whatever ohm is given, but that doesn't play any role in the circuit because the current through this is 0, 0 into this is 0, entire thing is 0. So condition will not be affected. The condition will remain the same. Then in this part current will not flow, so this will be taken as if it is not there in the circuit at all. It is out of the circuit, even if any resistance is given. But under only when the bridge is balanced, when this condition is satisfied. P by Q equal to R by S. So this one is quite important derivations. So today we are doing this much. Next day I will continue. Some problems also we have to do on this Keystone bridge.